A place to be, to groom your words, a place that is secured for the rest of mine. No other place but burial schools is the best.
Good morning, students of Berry. You are all welcome to today's meeting. Today we are going to learn on SS1 mathematics, and the topic is on laws of indices. But before I go on with the laws of indices, we have to throw more light on indices. In your SS2, we discussed indices there. We are told that 10 raised to 10 times 10 times 10 is equal to 10 raised to power 3. This is in index form, 10 in index form. Also, 4 times 4 times 4 times 4 is equal to 4 raised to power 4. 4 is also in index form. This is what we refer to as indices. But now we are moving further to the laws of indices. And the first law I will begin with is the multiplication law. We state that x raised to power a multiplied by x raised to power b is equal to x raised to power a plus b. You can see that multiplication goes with addition. X to the power of a multiplied by x to the power of b is equal to x to the power of a plus b. Now, let's have some examples. I start with example 1. Example 1. I have 5 to power 3 multiplied by 5 to power 4 is equal to 5 to power 3 plus 4, which is 5 to power 7. That is what it means, applying the same law. Now, let me give another example, example 2. I have 4c to power 3 multiplied by 3c to power 2. You can see that 4 and 3 are not in index form. The law can only be applied to all the letters or numbers that are in index form. In this case, the normal thing I will do is to multiply 4 by 3 and then apply the law in those letters or numbers that are in index form. Now see what it's like. I have 4 times 3, then I now put bracket c times c to power 3 times c to power 2. What do I have? I have 4 times 3 give me 12. case, I have x times x times x all over x times x times x. This cancel this, this cancel this, this cancel this. So I'm left with 1. You can see the same. Now to another law, which is the negative power law. And in negative power law, you can have x or any number raised to power negative number. We have 1 over that number to that power. As it is now, we can use it to solve anything in indices. Alright. Example number 1. I have a raised to power minus 3 divided by a raised to power minus 5. In that case, let me now apply this law. In solving this, I have a raised to power minus 3 divided by a raised to power minus 5. That gives me a. I have 1 over a raised to power 3 divided by 1 over a raised to power 5. You know, in mathematics, I can solve it like this. 1 over a raised to power 3 multiplied by, I now invert this. In mathematics, when you are changing your division to multiplication, you invert the next fraction. Now, it will become a raised to power 5 all over 1. In that case, what I have is, this multiplied this will give me a raised to power 5 all over a raised to power 3. And in that case, what do I have? If I know what I am doing, I'll still use the same method. I have a times a times a times a times a all over a times a times a. I have this cancel, this cancel. What I'm left with is a raised to power 5. Okay, let's go through this work again and see whether we got it all wrong. Alright, now I have a to power minus 3 divided by a to power minus 5. Now I start my working. I have, because it's obeying this law, negative power law, I have it here, we apply it here. A raised to power minus 3 will be 1 over a to power 3. I have removed the negative by putting 1 all over this. Now the same thing is applicable here, divided by 1 all over this. Now, let's work it out. I have 1 all over this. Multiply. Remember I said when you want to remove division, you now put multiplication, then invert the next fraction. I put division, I now invert the next fraction, which is supposed to be 1 all over a raised to power 5. Now a raised to power 5 comes all over 1. Now let's look at it again. I have 1 times this will give me this, and a to power 3 multiplied by now will still give me that. Now let's expand it and see what can cancel what. I have expanded this, a times a times a times a times a all over this, which is a to power 3. I have a times a times a times a. I start my cancellation of this cancel this, this cancel this, this cancel this. So we are left, oh, this is where the problem, we didn't get it right here. Okay, what is left now is a times a, which is a raised to power 2. This is our answer. Invariably, you can still use another method referring to the second law, division law. We can bring it here and still work it because it still obeys the division law here. There are 2 laws here. The division law is applicable and negative power law is also here. So let's use the division law to solve this. Now, I'm bringing it here. I have a to power minus 3 multiplied by a to power minus 5. So let me use the division law. Okay, we now have a raised to power minus 3. Remember, division goes with subtraction. If you can still remember the division law, I have minus. You base the law by putting minus because it's division. Now, I minus 3 plus 5 will give me 2. So you can see it's the same thing with this. Whichever way you want to apply, you can now apply and get the same answer. Okay, let's look at some of the examples using some of these laws that we have discussed. The second example I have here is, let's start with example 2. Solution to example 2. I have 10 raised to power minus 3. The same thing as, if you look at it, it obeys the law, the negative power law. So I can now say 1 over, I remove minus, I put 10 raised to power 3. And I can expand it to be 1 over 10 times 10 times 10, sorry. I can have it 1 over 1000. That is our answer. So, example number 3. We have x to power 0. Go. Okay, example number 3. I have, remember, the power 0 law. Each and every one of them obeys their law. So here, anything raised to power 0 is 1. I will put 1. Multiply by x to power 4. Then, this one is negative power law, which has to go with 1 over x to power 2. In that case, if this multiply this and multiply that, we have what? X to power 4 all over x to power 2. If I want, I can still use the same way. I have x to power 4, which is what? X times x times x times x all over we have product of indices. And in product of indices, we have something like x to power a or multiply by b. So in this case, what do we have? If we have this law says that when you have something like this, what you have is x raised to power a multiplied by b. What you give you is x raised to power ab. So now, let's use some examples to explain the law better. I have example number 1, which is x raised to power 4 or raised to power 2. So what I have now, for me to remove the bracket, I have x raised to power 4 multiplied by 2. And that gives me x raised to power 6. And that is what it is. So in example number 2, I have example 2, I have t, the same thing. We apply the same thing, which is t raised to power 3 times 5. And that is t raised to power 15. Remember, you can still do it in another way using that same method that you used in your junior class. I can still say, in this example 1, let's look at example 1. I have x raised to power 4 all to power 2. If x raised to power 4 multiplied by x raised to power 4. Can you see? X raised to power 4 is raised to power 2. So I have x raised to power 4 into 2. And when I do it, I will use the first law, the multiplication law, which is x raised to power 4 plus 4. And that is what? X raised to power 8. In that case, I've gotten what I want. So in the second law, the same, oh God. Okay, you can see that what we have here is x raised to power 8. Okay, x raised to power 8. Let's go back to cross shape and know whether it's the same thing we got in the first example. Okay, we said x raised to power 4 times 2. 4 times 2. No, it is not 6, it is 8. You can see they are now the same. Whichever one, any formula you know very well to apply, please apply them very well. You can arrive at the same answer. Let's go to the second example. I can apply the same method. I have in the second example, I have t raised to power 3 or raised to power 5. Remember, I'm using the normal method you know without using that law. Now I have here t raised to power 3 multiplied by t raised to power 3 multiplied by t raised to power 3. So in that case, I will now use the law, which says when you have the same multiplication law, I have t. Now I have all raised to power. I will now use addition to add all the powers. Plus this, plus this. Okay. This into 5. T raised to power 3 into 5. I have t times t times t, yes, times t raised to power 3 times t raised to power 3. You can see 1, 2, 3, 4, 5. T raised to power 3 into 5. Now I can use the multiplication law. I have t raised to power 3 plus 3 plus 3 plus 3 plus 3. That is 5. 1, 2, 3, 4, 5. What will it give us? This plus this plus this plus this plus this give us 15. You can see it rhymes with the first one that I knew. All of them are correct. Okay, coming to the final additional part of the topic, we have a fractional indices. In this case, we have x raised to power 1 over a and x raised to power a over b. Let's take them one after the other. I have x raised to power 1 over a. In this case, what I would have gotten is half root a, then x, this one will come and be here. Remember how I... Alright. I can use an example here to explain what I have done. For example, if I have x raised to power 1 over 2, in that case I have roots Remember, when we have 2 here, when we have roots, we don't normally put 2. But if it's cube roots, we put cube root. I have x raised to power 1, we don't normally put it, so I can put it like this. This is exactly the same thing. Example again, in another example, I can have x raised to power 1 over 3. In that case, I will bring into existence the cube root. This one, we have to come here, then x raised to power 1. Similarly, if I am using this, because the two are the same, if I am using this, what I'll have is x raised to power a over 3. B's, rather. So in this case, I have x raised to power a. The root of b, the root a to power x, the b will be outside. For example, I use a number to explain what I mean by such. I have something like 3, let me put 9, 2 over 3. Or rather 2. Let me put it like this, 1 over 2 or 3 over 2. This is 9. Look at it. It looks like this. So let's see how we can work with it. In this case, I have roots. 2 has to come here. The way there's 2, we don't normally write it. It's square root of 9 raised to power 3. And the square root of 9 is what? 3. 3 raised to power 3 will still give me 9. Alright? Sorry. 27. 27. Okay. Solving more examples. Let's take example number 8. I have 4 raised to power 1 over 2. That means root 4. And that is 2. That is the answer. B. I have 8 raised to power 1 over 3. That is cube root. Remember how I place it? 3 has to come before 8. Which is what? Root. Sorry. The cube root of 8 should give you 2. Now, example C.